Hello everyone, so this is the last lecture for this course. This basically covers chapter 6 and 7 in the book. There's material from outside the book in the lecture. So please pay attention guys, and basically the questions are going to cover whatever is in the presentation. So the homework questions. So let's see here. Total productive maintenance. So basically let's talk about the evolution of maintenance. The historical evolution. First, we have the corrective maintenance or breakdown. It was initially called breakdown maintenance until in 1957 when it was actually renamed as corrective maintenance. And the reason why is because basically breakdown means you just an equipment for example, fails to do something, you fix it, and then it comes back to how it was originally intended to be. So by corrective maintenance, the word indicates that you actually make corrections in the equipment so that you actually also improve it, not only fix it but also improve it. There's a room for improvement in it. So that's why it was renamed to corrective maintenance in 1957. Then after that came preventive maintenance. After breakdown maintenance, this was the initial objective of the maintenance department. This was breakdown maintenance. Then in the 1950s, 1951, basically, they started doing preventive maintenance. So in other words, before an equipment fails, actually do periodic checkups, regular checkups. Then after that was predictive maintenance. So as we covered before, predictive maintenance basically you use scientific methods and tools to predict when an equipment will fail, such as, for example, vibration analysis, for instance, to determine when is it, like if you remember, we talked about that everything will fail eventually from fatigue. So predictive maintenance, when you do a vibration analysis, you can predict when a fatigue failure will take place. Obviously, by detecting cracks and scratches on rotating and dynamic equipment. So maintenance prevention, introduced in the 1960s, basically is the design of equipment so that they are maintenance free. So basically you improve the design so that you reduce maintenance as possible. Reliability centered maintenance is the one that we studied in chapters 1 and 2. It's basically using statistics and mathematics to determine the reliability of the equipment and so on. Total productive maintenance basically is an integration of several things, and it includes the whole the whole plant or the whole corporate. All the persons are involved in the maintenance, from the top management to the operators. So this is basically a structural strategy introduced by Nippon Denso in 1971. It was actually, of course, it was part of the Denso is actually a supplier for Toyota. It's a car basically manufactures car parts for Toyota. So the Toyota production system is the one that initiated a lot of what we are going to see in this presentation, the Toyota production system. So something that is very important, a very good assessment tool, is the OEE, overall equipment effectiveness. It's actually probably the main one, the main assessment tool of how efficient is the maintenance, or how successful is the maintenance department. So the OEE is equal to the availability multiplied by the efficiency multiplied by the quality. So of course availability is the operation time divided by the net available time. The efficiency is the actual production divided by the full capacity production. Like for example, if you have a car plant that can produce, for instance, one vehicle every minute, or let's say, for example, it produces, for instance, let's say, okay, 60 vehicles per hour, but it produces, for example, but its actual production was, for example, 40 vehicles per hour. Okay, so this here, then you divide 40 divided by 60. Quality is the number of useful products divided by the total number of products. In other words, the percentage of the useful products to the overall number of products produced. In other words, you take off the faulty products. Typically, the quality has to be around 95% or higher. So lower than 95%, that means it needs improvement. 10%, for example, faulty parts is actually high. It needs to be improved, for example. So let's take this example here. A plant has the capability to produce 800 radio units per day. Its actual production was 520, so 520 over 800. Of the units produced, 486 of them were good and the rest were faulty. The actual production time per day was 600 minutes out of a 12-hour available time for operation. What is the OEE of the plant? So as you see here, first we have to find the availability. So availability is, we have 600 minutes, that means 10 hours, out of 12-hour work per day. So in other words, we have 600 divided by 720. Then we have the efficiency was 520 over 800, 520 parts produced, but its capability, its full capacity was 800. Then we have the quality, we have 486 over 520. So when you multiply these three, you get 0.5063. So in other words, you will see that actually if you want to improve, you want to make an improvement, you can improve any of these three, any one of these three. Okay, like for example here, the quality, if you want to calculate it here, for instance, let me just pull the calculator. So if we calculate, for instance, 486 divided by 520, 486 divided by 520, we get 0.934. So in other words, 93.5. So 93.5% is the quality. So we have 6.5% faulty parts. That means you can actually improve there. There's actually a room of improvement that you can do. So this here is the OEE. It's actually very effective tool for assessment of the well, as the name suggests, overall equipment effectiveness. It's a very, very useful tool. So some techniques used in total production maintenance. So here we have some techniques that are very commonly used and very useful and actually universally known. The 5S. So the 5S, we talked about this in class. It's very, very effective and very popular. So this is a method that was used for organizing the workplace, and eventually it leads, of course, to increased efficiency and profitability. So actually 5S is, like I said, it's very, very popular and very useful, and it's applied almost everywhere. And here's the thing is that in any language, anywhere you go, it's still the 5S actually start with the S. So in Japanese, actually, they actually say each of the fives starts with an S. In English, the same thing. In German, the same thing. In Spanish, so it's actually universal. It's 5S everywhere. We're going to talk about it in a minute. The 5 Whys technique, it's less popular than the 5S. Well, I mean, of course, it's actually for troubleshooting, but I mean, it's not as known as the 5S. It's basically you ask why 5 times until you get to the root of the problem. Another troubleshooting technique that is used is the fishbone, the Ishikawa. So the fishbone Ishikawa is a graphical method. Basically, you draw something like a fish, and then you find for example, a problem. You have a problem here. What can be the possibilities that cause the problem? There's also the check sheet, for example, using a check sheet, So there's actually many troubleshooting techniques, but these are like some popular ones. So these are maintenance techniques. There's also a process improvement. So process improvement, there's two very popular methods that are used. One of them is called Kaizen. So Kaizen is another Japanese word, which means continuous improvement. Okay, so Kaizen is very popular. Means it's actually two words, Kai and Zen. Basically, it means in English continuous improvement. Some methods that are used in Kaizen are also popular. Like for example, the poka-yoke. The poka-yoke means in Japanese mistake avoidance or mistake proofing. Actually, the original name of it, when they first invented it, all of these come from the Toyota production system, by the way. So when it was first invented, actually, the name used to mean something like stupid proofing. But then they found that the name is not suitable, so they actually changed it to mistake proofing or mistake avoidance. So what it means is that you design the equipment such that you prevent any faulty operation. Like for example, for instance, here the interlocking of a motor. You know that we actually talked about that in an H bridge. When you want to control a motor forward and reverse, the circuit that is used is called the H bridge. And the H bridge basically has 4 contactors. If you use contactors, it will have 4. 2, for the forward and 2 for the reverse. Now, if you at any time energize both the forward and the reverse contactors, what's going to happen? You're going to short circuit the power supply. Very dangerous. So you have to avoid that. How do you avoid that? You interlock the forward and the reverse contactors. How do you do the interlocking? You can do it actually mechanically or electrically. So this is an example of a poka-yoke. For instance, if you have, for example, a process in which there's a sequence of events that have to take place. Like for example, you have to, for instance, mix 2 chemicals, but first you have to, for example, first you have to basically get water, put water in the reaction tank, and then after that you put for example, the base or the acid. Typically, this is the situation is. So so in other words, there's a sequence. So then what you design the equipment such that if the operator tries to, for example, insert a base before the water, they cannot. Okay, so they are forced to follow the sequence. So this is called poka-yoke. There's another method used in Kaizen, which is the 7-way, or actually not a method, but let's say a guidance technique, is the 7 wastes. The 7 wastes basically means you want to reduce, when you want to improve a process, you can actually reduce one of the 7 wastes or mudas. Okay, it's also Japanese, originating from the Toyota production system. Basically, we're going to talk about it in a minute. Then, so this is the Kaizen. Kaizen is very popular. Then there's the Six Sigma. Six Sigma was invented in Europe in the 1980s, and the main difference between the two, they actually both really are process improvements, similar, but the main difference is that Six Sigma is really on the product. So everything is related to the product, the final product. Like for example, improving the product quality while maintaining the cost. For instance, or for example, reducing the faulty parts, like we saw before, reducing the faulty parts, the percentage of faulty parts from 93.5, for example, from 6.5% to, for example, 5%. So basically, it's related to the product, the final product. Kaizen doesn't necessarily relate to the final product. Any improvement, like for example, reducing, reducing or making a more efficient storage space, then that's Kaizen. Okay, or for example, reducing the costs, for instance, that's Kaizen. So anything really that can cause an improvement, Kaizen actually works on that. Six Sigma is really only for or concentrates on improvements related to the product itself. So let's talk about 5S. Very, very popular and very important, and you need to memorize actually the 5S. So as you see, we talked about this actually in class. Sort, set in order, shine, standardize, and sustain. The 5S. It's actually very, very effective, and the reason why it's very effective is because it can be applied anywhere in the company, from the top CEO all the way to the operator. Everyone applies 5S in their workspace. And the idea behind it is that the tiny little problems, they build up to make big and major problems. There's many examples that we can talk about. For example, the example that I like is if you have, for instance, an engine. Okay. For example, an engine, if you don't take care of it, and if it looks, if it's dirty, and over time, what happens is that if you have an oil leak, you will not be able to find the oil leak to detect it. But if you keep it clean, if you keep it super clean all the time, any tiny oil leak, you will detect it right away, and you will take care of it before it causes you bigger problems. So this is basically the idea of 5S. If you take care of the little problems, you will avoid the big problems, and it is very effective. That's why it's applied everywhere. So a good way to memorize it is basically, you can imagine, like for instance, like I think I gave this example in the class. Imagine that you found a treasure, okay, a box of treasure in your farm, for example. So then what you do, you sort out, for example, the let's say the mud and things are not needed from the coins, for example, the old coins, and then you basically set them in order, for example, quarters and dimes and pennies and so on. Shine, you clean them, you clean everything. Standardize, so let's assume you found another box, then you basically make this a standard to follow that. And sustain, basically you keep doing the same over and over. So this is the 5S. It's very effective. The 7 ways, basically it's good to know, because if you reduce any of these 7 ways, then you are doing Kaizen. You have an improvement. Okay. I'll give you an example, a very good example actually, just in a minute, but let's look over them. So the 7 wastes. So overproduction is a waste, and probably you have seen on the news actually recently, for example, oil, crude oil, for instance. Overproduction of crude oil causes the prices to go down. In fact, it became negative actually, because there was no place to store the overproduced oil, for example. So overproduction is a waste. Waiting, so cost of having the product waiting in a queue, this is a waste. Time, with time spent for nothing. Transportation costs due to moving the products, so we need to reduce transportation as possible. So there's actually, when I went to Siemens in Germany a few years ago, they actually told us that they applied Kaizen, and they reduced about, I can't remember actually what did they produce in that plant, but what they did actually, they reduced the overall transportation of in the plant basically by 1 mile. How did they do that? They just rearranged the locations of the different cells, in the plant. The idea was that you should never cross, hands, or if there's 2 operators, they should never cross, to pick up something from here. So if you ever cross your hands, that means you need to get whatever is here there, and whatever is here is there. Okay, so crossing hands basically means you are wasting. There's transportation waste. An operator crossing the other operator, that means there's a transportation waste. So basically, the idea is to reduce that. So inappropriate processing, for example, using expensive high precision tools in place of simpler tools, obviously this is a waste. unnecessary inventory, defects, something that is always the plants look for reducing that. Excess motion causes wear and tear on equipment used in the process. So all these are waste. Reducing any of them is an improvement in the process. So the 5 whys, it's not very popular, but I mean, it's a good, let's say, a good practice is to ask why 5 times. Like, for example, why the workpiece stopped at station 3. Like this is an example is for a trainer, let's say a mechatronics trainer. So why did it stop at station 3? Because the eject cylinder did not extend. The eject cylinder that basically transports the workpiece from one place to another did not extend. Why did not extend? Because the solenoid did not energize. Why the solenoid did not energize? Because the PLC did not send the signal to the solenoid. Why the PLC didn't send the signal to the solenoid? Because it didn't receive a signal from the sensor. And why the sensor didn't send the signal to the PLC? Because the sensor has no power, for instance. Okay? So the 5 whys. Paths to process improvement. So there's actually 3 paths to improve a process. So the first type, or let's say the first path, is innovation. In other words, you introduce a new process. For example, the R&D department, for example, they came up with a new tool. They actually are going to introduce a new tool. So the thing is here, the benefits can be very high from introducing the completely new process or the completely new change, but drawbacks can cause a significant failure. So in other words, it's a gamble here. It can benefit you a lot, or it can significantly affect you. Okay, so for example, introduction of a new product that requires a new processes. Like for example, they did an upgrade on some equipment on some product that basically changed, how it's designed, or So in this case, you can have actually it can be a remarkable benefit, or it can cause significant failure. Then let's say, to a less extent from that is a simple change. So introduction of a new element in an existing process, it can have significant benefits, but there's going to be less of a risk. Okay, the change can be slow and difficult. There's less of a risk. Like for example, introduction of a robot for material handling in place of manual labor. It can be slowly progressing because they have to learn on the operating of the robot, but the benefits can be significant. The easiest of these is imitation. So imitation basically, like for instance, if you have a tire plant here and the tire plant, for example, in Ohio. Then the tire plant in Ohio, they actually introduced a new process, and they found that was actually very successful. So what you do, the tire plant here imitates what they did over there, and there's going to be, of course, a lot less of a risk because it has been already studied and it has already proved to be successful in a similar plant. So it's introduction of a process or an element of a process that is already being used somewhere else. Highly predictable, of course, outcomes and low risk of failures. So as an example, introduction of a tool in manufacturing process that has been proven to be successful, a successful addition in the same process in another plant. So there's something that's very, very important is why do you need to involve the operators in maintenance? So actually something that is important is that you should always, as a technician, you should always communicate with the operators. Okay, you should communicate with the operators because the operators, they are the ones who know really what happens. Okay, so they know where, for example, if there's a machine that is if they hear, for example, a knocking sound every time, for instance, every time, for example, the machine passes, let's say 2000 RPMs, for instance, then they know what's the problem. They know what's actually what's going on. But the technician might not, might not know that. Like for example, for instance, I'll give you an example. For example, a very common problem and a very difficult problem is when the failure is electric, but or actually not the failure, but let's say something stops that is electrical component stops, but the actual failure is actually mechanical. Like, for example, an overload. An overload trips. You know, an overload basically is an element that detects current overloads. And if the motor, for example, draws large current, it actually stops it. It trips and it stops it. So a very common problem is basically when the overload trips, but not because the motor is overloaded, but because the bearing is not lubricated. Okay, the bearings basically when they need lubrication, what happens? They will the friction will cause overload and the motor will stop. So this problem actually is difficult to find. What happens is that they will the technicians when they see an overload trips, they will basically try to oversize the overload relay. They'll think it's undersized, or they will replace a thing that's went bad, but it keeps tripping. And so when the problem is actually the bearings. If they communicate with the operator, they will know, for example, that there is the operator, for example, hears a sound, for example, a friction sound. So the operator actually knows the problem. That's why a lot of companies, like Siemens, for example, actually what they did, they introduced a program to train the operators on simple maintenance. Okay, because it's going to be extremely effective when you train the operators on. They can pinpoint for you the problem more. Like for example, if the operator doesn't know how the machine works, they'll say, "Well, I hear a sound, but I don't know where it's coming from. Somewhere from there." But if they are actually trained, if they receive educational programs, they'll know, oh, okay, well, I hear the sound from the bearing, for instance. So it's very effective to communicate and to train provide training programs to the operators. So there's a Japanese scientist, Yoshida. He came up with an idea that's called the iceberg of ignorance. So it's really, I mean, it's really a descriptive idea. The iceberg is a very good word because, you know, if you take a cube of ice and put it in water, 90% of the ice actually is under the water surface, and only 10% is above the water. So what you see here is just the tip of the iceberg. Most of the iceberg is actually down under the water. And basically what it means, the idea is that the CEO is that basically the people who know really the problems are the operators. So the frontline operators, they know 100% of the problems. The supervisors, as you see, know 74%. The middle management, about 9%. The CEO who runs the company actually knows only 4% of the problems. So the idea is that to be successful, you need to communicate with operators all the time. You need to keep good relationship with operators because they are the ones who know the problems that actually exist. The same thing for a technician, basically. You need to communicate with the operators because they know they can pinpoint for you the problem. So maintenance safety and accident prevention. This is going to be the last topic we're going to talk about is maintenance safety. So there are actually the number four ways of OUR of hazard avoidance. So to basically avoid hazards and accidents, there's four approaches: analytical approach and engineering, enforcement, and psychological. So the first two, analytical and engineering approaches, these basically they form barriers. So they basically they put barriers between you and the hazards. Okay, so how is that? So but the barriers can be, of course, physical, like for example in the design of the machine is designed such that, for example, for instance, if you have a press, for example, a press where that exerts high extreme pressures to basically for instance, some of them will require you to have with two push buttons. So in other words, you have to have both hands of the operator must be hitting the two push buttons in order for the press to come down. Of course, the purpose of that is to make sure that both hands are being used to operate the press. So as a safety measure. So this here is an engineering approach, the design. Also, for example, the protective equipment, the safety glasses, and for example, if you need also helmet and so on. Analytical approach means the procedures. Okay, so for example, first we have to, for instance, de-energize, you have to turn off the power, then you have to make sure that, for instance, the pneumatic lines are off and so on. So the procedures, so procedural approach, and there's engineering approach. Okay, so these are basically barriers between you and the failures. Then there's enforcement and psychological. So these are basically, let's say these are the last lines of protection. These basically are there to reduce the human error and reduce the unsafe acts. Okay, so these are basically enforcement, such as the laws, in place, like for example, lockout, tagout, and for example, psychological, like for instance, having an environment or basically a safety climate in the company. So let's look at them. The analytical approach. Analytical approach basically some methods are used, very, very popular, or actually always exist everywhere. Accident root cause analysis. So this here, the root cause analysis, is done after an accident takes place, and its purpose of this study is to pinpoint the root cause of an accident so that you can prevent it in the future. Okay, so the root cause analysis, it's very, very it's always actually implemented. Then there's another very, very important one, which is the FMEA, failure mode and defect analysis, and we're going to talk about it in a minute. So it's also very, very popular and is used really everywhere. Basically, here you have to find something called the RPN, the risk priority number. So identifies the possible failures that may occur and the results of the failure modes and their severity. Fault tree analysis, like a tree model, a chain, a chart that will tell you if you, the probability if you do this, for example, you're going to go this, and if you do that, it's going to be the result. The consequences of this are going to be that, and so on. So it's basically a tree model that shows chains of cause and effects that lead to undesirable outcomes. Then there's the hazard and operability analysis. This is basically you study basically a process for the purpose of only finding and locating safety risks. Okay, so you look at a process basically, and you just find any place of safety risks. You know what they do actually for this? For example, they have OSHA. They have something that looks like hands, human hands. It's actually, of course, it's like a finger. And what they do, they actually try to, for example, find places where you can actually stick a finger and in a rotating equipment, for example. So basically, it's a study where you are trying to find any and locating any risks of that can cause safety, that can be actually safety risks. So the engineering approach, basically here, there's the engineering controls. These are the designs in the equipment for safety. For example, the fail-safe mechanism, like for example, a fuse. Okay, having a fuse, for example, to protect from short circuits. Okay, overloads and short circuit protection, e-stop requirements, and so on. So this is the design of the equipment so that it basically prevents any safety risks. Then there's the procedures, the safety procedures, basically. For example, lockout, tagout, this is work, not work. This is work order requirements, maintenance work procedures, and so on. So these are basically in place to make sure that you follow the safety precautions. Like for example, work order requirements. The necessity of them, for instance, is because uh, it's basically the job is described in writing. Okay, just to make sure that the operator and the technician are on the same page. Okay, there's no misunderstanding. Okay? To make sure there's no misunderstanding between the operator and the technician. So in other words, they actually know what exactly is gonna happen, what's gonna be taking place. So personal protective equipment, of course, such as, for example, gloves, safety glasses, helmets, safety shoes, earplugs, and so on. So these are the engineering. This is the engineering approach for safety. The enforcement approach, of course, this is basically the laws and the regulations and the legislation that is available in regards to personal safety, such as, for example, OSHA. In the United States, OSHA. The international, for example, is the International Labor Organization, ILO. Notice, for example, here, the International Labor Organization, the labor here has it written, LABOUR, the British, basically. The European Agency for Safety and Health at Work. In Canada, for example, the Canadian Center for Occupational Health and Safety, and so on. So these are basically the ones that regulate and organize the safety related standards. Finally, the psychological approach basically refers to the culture, so the safety culture in the workplace. So it's very important to have positive safety culture in the workplace. This is basically to avoid resistance to safety programs. Okay, it's important that everyone, from the top management to the operators, everyone actually looks for safety. So basically here, safety is highly valued in all activities. Everyone from the upper management to the operators are involved in ensuring safety and safe practice and conducting regular safety trainings and exercises. This is important to avoid resistance. Like for instance, in one of the classes that I taught previously, years ago, uh, the students used to come with shorts, and actually I forgot to mention, for example, in the syllabus that you need to you cannot actually wear shorts. And so I had to tell them all the time, well, you can't, you have to basically, you can't wear shorts. You come to no shorts, for example, flip-flops and so on. So you need to encourage, you need to have this environment of safety. Everyone, actually, not only the teacher, I mean, not only the top manager, but everyone uh, needs to value safety. This is basically, like I said, to avoid any resistance in applying safety programs. And this is very important to have in the workplace. So this is the psychological approach. Finally, let's talk about failure mode and effect analysis. It's very important. And basically here, what you do, you find the failure modes in a process. Okay. So focuses on single point of failure analysis, use inductive reasoning, goals to minimize failures, especially catastrophic ones. So here there's a very, very important number called the risk priority number, RPN. So RPN means is basically, there's three parts in it. There's the severity of the failure, how severe it is, the occurrence, there's the probability of the failure, how probable it is to take place, to happen, and detection, how much are you able to detect the failure. Typically, mechanical failures can be detected easily. Okay, electrical failures are not easily detected. All right, or for example, temperature is not easily detected. Increasing temperature is not easily detected. So what happens here? You need to basically make a chart, basically, of each of possible failures in a process. Okay, possible failures, and then you find these three numbers in them. Each one of them is from 1 to 10. Okay, so 1 is the minimum. You cannot have really. You can never have a severity of 0. Okay, severity at least 1. 10 is the maximum. In other words, the worst. Okay, the same thing for the occurrence. 1 means it rarely occurs, but you should never have never occurrence. Okay, so 1, 2, 10. 10 means it occurs very, very often. Okay, section, the same thing. Section means 1 means it is easily detected. Okay, 10 means it is very difficult to detect. All right, 10 means it is very difficult to detect. So then, so you multiply the 3 numbers to get the RPN. Now the question is, what's the maximum RPN you can get? Of course, it's going to be 10 multiplied by 10 multiplied by 10, so that's going to be 1000. Okay, what's the minimum RPN you can get? It's 1 multiplied by 1 multiplied by 1, that's going to be 1. So in a process, in a typical process, you want to have basically the RPN. Typically, for example, in the projects that the capstone projects for the for when you take the capstone project, I ask you actually to do the FMEA for your project, and typically for you will never have, let's say, an RPN. Let's say, I mean, it should be like at least around 100. The reason why below that, it's because, I mean, like for example, if it was like I said, I give that an example. That example is if you have an iPhone, for example, you can have actually iPhone has been tested billions of times by billions of people, so it can have actually a very low RPN number. But for something that you produce for the first time and tested it only a few times, there's no way you can have like 10 or 20 or 30 RPM. So basically you have to typically should have in the hundreds for that. So so eventually it's actually subjective. It depends on the person, but also I mean it has to be basically usually it's someone who is experienced, the person who does or the team that does failure mode and defect analysis. So after analysis is performed, an action plan is developed based on the RPN. The action plan recommends fixes and or modifications to reduce the RPN. Then after that, a new RPN is developed after fixes are applied. Typically management uses the new RPN as a basis for fixes and changes. So this actually brings us to the end of this presentation. And I'll put the homework questions in a minute on Canvas. If you have any questions, please let me know. Thank you so much. Bye.